Hi everyone, in this video I'm going to show you how to evaluate limits from a graph that is given to you. If you want to hone your skills, I invite you to pause at any time and try and figure out the answers for yourself. Anyway, let's jump right into it. Okay, so the limit of a function tells you what the y value of the function approaches as x goes to a certain value. The limit of a function does not tell you what the function actually is at that x value. So to illustrate what I mean by that, I'm going to look at this crazy function I've drawn here on the left here. So I'm going to start by looking at the limit of the function as x approaches 10 from the left. That's what this minus sign in the exponent indicates. So as x goes to 10 from the left, it approaches the y value of 0 because the function is 0 on the x-axis. So this is 0. And I'm going to look at the same limit. X approaches 10, but this time from the right. So as x goes to 10 from the right, the function gets higher and higher and higher, and eventually it hits 0 as well. So the limit from the right is 0 as well. And because the left and the right-hand limits are the same, we say that the limit of fx as x approaches 10 is 0. So the limit exists. This is typical of a point on the function that is continuous. Here on the function, you can see several holes or open circles where the function is discontinuous, and it's at these points where the limit may or may not exist. Let's have a look at the limit as x approaches -8. So the limit as x approaches -8 from the left of the function fx. So from the left, the y value, it gets closer and closer to, it looks to be about -6. So again, the limit tells you what the y value is as the y value of the function as x approaches -8. And I'm going to look now at the limit as x approaches -8 from the right. And the function, it approaches the same value, -6. So the limit of the function as x approaches -8 is -6. So even though there's a hole here, even though the function itself is -3 at x equals -8, the limit only tells you what the function approaches at that value of x. So that's important to keep in mind, because some functions are undefined at certain values of x, but we're still interested to know what the function approaches near that value. So that's where the limit is important. All right, let's have a look now at x equals -2. All right, so the limit as x approaches -2 from the left of this function. All right, so if we approach from the left here, the y value approaches +3. Let's have a look now at the right. So the limit as x approaches -2 from the right. Let's see. So from the right, the function goes higher and higher and higher, all the way up to 7. So from the right, the function approaches the y value of 7. Now, because the left and the right-hand limits are not the same, the limit as x approaches -2 of the function does not exist, also known as DNE. That's a common abbreviation in these in calculus. So So yeah, the limit of the function as x approaches -2 does not exist. Let's see, what else can we look at? Let's have a look at as x approaches +6. Limit as x approaches +6 from the left. Let's start with that first. So the y value of the function as x approaches 6 looks to be about +2. And we can look at the same thing on the from the right. So the limit as x approaches 6 from the right, as x approaches 6 from the right, the function, the y value is 5. And because because the left and the right hand limits are not the same, the limit as x approaches 6 of the function does not exist. So even though the function is defined at x equals 6, it's 5. The limit does not exist at this point because the y value approaching from the left is different from the y value approaching from the right. So the limit itself does not exist even though the function does. And we could stop there, but I'll give you just a few more limits just for fun. So let's talk about the limit of the function as x approaches +12. Now, we can only talk about this limit from the left-hand side because we can't see anything about the function from the right side. So we can only calculate the limit as x approaches 12 from the left. All right, so what is the y value as x approaches 12? That's this point here. So the y value as x goes closer and closer to 12, it's going to be -4. And that's all we can say about it. We can't see what the function is to the right, so we can only calculate the left-hand limit. All right, the final limit I'm going to look at in this video is, let's have a look at the limit as x approaches -12. So that's going to be this point here. So the limit as x approaches -12, and now we can't see what the function is to the left of -12, so all we can say about it is the limit as x approaches -12 from the right side. So we put a plus sign here. And now we look at the y value as x goes to -12. So it goes higher and higher and higher and higher, and the y value is +4. All right, so hopefully you have a better understanding now of how to calculate limits from a graph. Thanks for watching.